When an application reports too many database connections, the obvious reaction is to raise the limit or kill idle sessions. That can move the failure from connection refusal to memory pressure, unstable latency, or a larger outage. Treat the alert as a symptom, not a diagnosis. First, prove whether the database is actually near its limit, how the current sessions are distributed, and what changed in the same time window. Separate two different failures. A database may be close to its configured connection limit. An application may also time out while waiting for its own connection pool even when the database still has headroom. Align database connections, active and idle distribution, transaction age, connection errors, application pool usage, request concurrency, and recent releases. A pool timeout alone does not prove database exhaustion, and a high connection count alone does not prove a leak. The first collection step should be bounded and sanitized. The MySQL card returns one instance level row with the configured limit, current and running connections, historical peak, approximate headroom, and selected global error counters. The PostgreSQL card returns the limit, reserved connections, active and idle client distribution, approximate headroom, and a visibility status. Neither card returns SQL text, object names, usernames, application names, client addresses, connection strings, or raw session identity. Missing visibility should fail closed or return an explicit insufficient visibility status. It should not trigger automatic privilege expansion. These are isolated synthetic results, not production evidence. On MySQL 8.0.46 and 8.4.10, the contract observed one baseline connection and 7 connections under 6 additional synthetic clients. PostgreSQL versions 14.20, 15.18, 16.14, 17.10, and 18.4 passed the same baseline and synthetic pressure structure. The arithmetic for limit, current use, active or idle distribution, and approximate headroom was checked, but approximate headroom is only a value at one moment. It does not reserve space for future requests, operations access, background work, memory limits, or the application pool. One snapshot cannot prove why connections accumulated, whether the condition persisted, which transaction or request owns them, or whether more connections are safe. It cannot distinguish a missing connection return from slow downstream work, retry amplification, authentication failures, network interruption, or a recent release. It also cannot calculate the rollback cost of terminating a session. Root cause needs adjacent snapshots and aligned application, transaction, resource, error, and release evidence. Stop and contact the system owner if observation requires permanent privilege expansion, if sensitive output would leave an approved environment, or if diagnostic authority is unclear. Also stop if anyone asks to kill sessions. Terminate a PostgreSQL backend, change max connections, restart the database, scale infrastructure, or modify the application pool without impact analysis and a rollback plan. Observation should reduce uncertainty. It should never become an unreviewed production change. Use a simple evidence-first sequence. Confirm the symptom and time window. Collect the bounded capacity snapshot. Align session mix, transaction age, pool behavior, host resources, errors, and recent changes. Then choose whether to contain traffic, fix connection return or transaction behavior, continue observation, or request a separately authorized capacity change. The reviewed MySQL and PostgreSQL cards, synthetic samples, version boundaries, and stop conditions are linked in the canonical Surance guide below.